Okay guys, I thought it was time to have a crack at 2017 Methods Exam 1. I haven't done it since last year, so hopefully we'll be able to get through it okay. From what I remember, it's an annoying exam because they put some stuff in it that probably shouldn't have been in it in Methods. Well, the concepts and not what we teach in Methods. I'll explain it to you as we get further on. Okay, so here we've got a question, differentiate with respect f with respect to x. So we've got a u on v. Oops, I might make that a bit thinner. Okay, so u on v. So u is x, v is x plus 2, u dash is 1, v dash is 1. Now it's worth 2 marks. If you didn't show this, but you still got it right, they would give you 2 marks. But if you did show this and then stuffed it up, they would give you 1 mark for your method. So even if you did stuff it up, they'd still give you 1 mark. Okay, so we've got a quotient rule problem. So f dash of x is v times u dash, which is x plus 2, minus u times v dash minus x on v squared, x plus 2 squared. Make sure you simplify it, 2 on x plus 2 squared. Okay, here g dash, evaluate g dash of 1. So this is a 2 marker. So I'm just going to quickly differentiate this, bring our 3 down to the front, multiply it by the derivative of the bracket, negative 3x squared, multiply it by the bracket, and subtract 1 from the power. And then we're going to sub in 1. So I get negative 9 times 1 squared, 2 minus 1 cubed squared, negative 9 times 1 times 2 minus 1 is 1, squared is 1, so our answer is just negative 9. It's nice and easy to start off. Okay, like with the first derivative, here it's a product rule, don't necessarily have to show it. So u is x, v is log e 3x, u dash is 1, v dash is 3 on 3x, which is 1 on x. dy dx is v times u dash log e 3x plus u times v dash, so just 1, because x times 1 on x. Okay, hence, so here it's a integration by recognition. 1 to 2 log e 3x plus 1 dx. Okay, when we integrate that, we're going to end up with, if we diff that, we get this. So if we integrate this, we get that. So it's x log e 3x between 2 and 1. So first bracket sub 2 in, 2 log e 6 minus 1 log e 3. They're probably looking for you to mistakenly join these two together. But first, write log e of 36, because that goes up and becomes 6 squared, minus log e of 3. Remember, you've got to simplify it, so it's just going to be log e of 12. It has to be in that form. Okay, don't miss this restriction. Okay, show that that's that, so let's just expand it. So x plus 2 squared, x minus 1, x squared plus 4x plus 4 times x minus 1. I would show the next expansion as well. X cubed minus x squared plus 4x minus 4x plus 4x squared. So that times that. Minus 4x, then plus 4x, and then minus 4. I actually wouldn't even pay attention to adding them together because I know it's got to end up being 3x squared minus 4. However, it's a good check to make sure you haven't stuffed anything up. So x cubed My x squared, I've got 4x squared minus x squared, which is 3x squared. And then I've got they cancel, and I end up with minus 4. So we know that it's right. Sketch the graph. Label the axis intercepts and stationary points with their coordinates. Okay, so we've got a y-intercept, which is -4, and it only goes to there. So -4. We have got -2 is a repeated factor, so that's a turning point. So -2, 0, 0, -4. And on our endpoint, -3, if we sub it into there, we get 1 squared times -4, which is -4. So 0, -4, -4, -3, -4, sorry. Okay, so my graph's got to go through those points. We know that one of the turning points is that one, but we need to find out other turning points. So if we say f dash of x is, just simply derive this, 3x squared plus 6x, f dash of x equals 0. So I get 3x, x plus 2 equals 0. So x equals 0 or -2. Now we knew 0 was a turning point. Oh, we knew -2 was a turning point, but 0 is as well. So it means it's got to be flat here. So our graph's going to look, because it's a cubic, it's got to turn there. Then it's got to come down and look like it's getting flat at this point. Right? So that'll be what they're looking for to make sure, because some students would do like that, but it has to get to 0 because it's got to be at 0 at that point. So I guess that's what they're testing there. Okay, in a large proportion of fish, the proportion of angelfish is 1:4. Let p hat be the random variable that represents the number sample proportion of angelfish for samples drawn n from the population. Find the smallest integer value of n such that the standard deviation of p is less than or equal to 1 on 100. Okay, so our formula is p1 minus p on n is less than or equal to 100. 1 on 100. Okay, so p is 1/4 times 1 minus p, 3/4 on n. Now I'm just going to square the other side. So I'm going to say less than or equal to 1 on 100 times 100, which is 10,000. Okay, so on top we're going to have 3 on 16. That's that. I'm going to multiply the 10,000 across. So there to there. And I'm going to multiply that n across to there. So I get is less than or equal to n. Now you might ask, why did I leave the 10,000 like that? What I'm going to do is divide it by 4 and that by 4. So I get 4, and that's going to be 2,500. Then I'm going to divide the 4 into the 2,500. So 4's into 2,400. Actually, you can just do the whole thing. So 4's into 2,500. 4's into 2 doesn't go into 25, goes 6 times with a remainder of 1. 4's into 10 goes twice with a remainder of 2, 625. So on top, I get 625. So n is greater than or equal to 3 times 625, which is 625 times 3. 5, carry the 1, 3 2s is 6, 7, 1875. So n is greater than or equal to 1875. Therefore, the smallest value is 1875. Obviously, you don't have to show that working out. I only did it so that you knew what I was doing. But yeah, so that's how, because it says find the smallest integer value. So you don't have to put a range, you just have to put a single value such that the standard deviation is less than or equal to that. Okay, for Jack to log onto a computer successfully, Jack must type the correct password. Unfortunately, Jack has forgotten his password. If Jack types the wrong password, Jack can make another attempt. The probability of success, so P is 2 on 5. On any attempt is 2/5. Assume that the result of each attempt is independent of the other. a maximum of 3 attempts can be made. What's the probability that Jack does not log onto the computer successfully? So if he fails, so he's got to fail, 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 because he gets 3 shots, which is 27 on 125. Okay, calculate the probability that Jack logs onto the computer successfully. Well, that means that he doesn't fail. So it's 1 minus 27 on 125, which is 98 on 125. The other way you could work that out, logs onto the computer successfully. Okay, so he can either do it on his first attempt, or he can stuff it up and then do it, or he can stuff it up, then do it. Okay, they're all going to be on 125, so I've got to times that by 25, so I've got to times the top, so I get 50 on 125, plus, that's going to be 25, so I've got to times it by 5, so I've got to multiply the top by 5. So 3 2s are 6, times 5 is 30 on 125, and then here 5 5 5 is 125, 3 times 3 is 9, times 2 is 18, 80, 98 on 125, so now we haven't stuffed anything up. Okay, calculate the probability that Jack logged onto the computer successfully on the second or the third attempt. Express your answer in the form C over D. Okay, so that's that and that added together. It's also that minus that. So it's 98 on 125 minus 2 on 5, which is 98 on 125 minus times the bottom by 25, so 50 on 125, which is 48 on 125 as an integer. So that's it. You could have also added those together. 38 plus 18, which is 48 on 125. I remember last year we hated this question because it says state all possible values of tan theta. Well, tan theta can be any real number, but they were referring to this. I don't like this question. Anyway, so here, if we solve that, we get tan theta is equal to 1, because tan theta minus 1 equals 0. Here, you get sine theta is equal to root 3 cos theta. So when we set that equal to 0, then we bring that to the other side, it becomes positive. Then we divide by cos, so I get tan theta equals root 3. And then also here, it's the same thing, but it's going to be tan theta is negative root 3. Okay, so hence find all possible solutions for these. That is just that when I've separated apart as a difference of 2 squares. And it's between 0 and pi. So, okay, if tan theta equals 1, that special triangle is 1, 1 root 2 and pi and 4. So it's only positive in the first quadrant, so theta will equal pi on 4. Next, if we've got tan theta equals root 3, so 1, 2, root 3, it's got to equal pi on 3, because opposite over adjacent. If tan theta equals negative root 3, that's the same thing, but it's in the second quadrant, because tan is negative in the second quadrant, so it'll equal 2 pi on 3. Because if it's pi on 3 there, it's pi minus pi on 3 there. So they are our 3 solutions. Okay, don't forget to look at the domain. So here, state the range of f. So it is a square root graph. It's only from 0 to infinity. So if we put 0 into that, we get root 1, which is 1. If I put another good number is 3. If I put 3 into that, I'm going to get 2. So we know it's going to go up to infinity. So my range, f of x, is an element of 1 to infinity. State the largest possible value of c such that the range of g is a subset of the domain of f. Okay, the domain of f is from 0 to infinity. So x squared plus 4x plus 3 has to be greater than or equal to 0, because the range of that graph is that, x squared plus 4x plus 3, and it's got to be greater than 0. It's also got to be between negative infinity and c. So if we factorize this, we get x plus 3, x plus 1 is greater than or equal to 0. If we sketch that, we get negative 1, negative 3. Now, our domain has to be from negative infinity up until c, and it can't be less than 0. So our magic value for c is c equals negative 3. You couldn't have negative infinity to negative 1 because here we're going below 0, but the function is only greater than or equal to 0. So it makes sense that c equals negative 3. So that's the largest possible value of c for this function to be correct. For the value of c found in part B1, state the range of f of g of x. So my range here is 0 to infinity. So if I use negative infinity to c, the range of this function is going to be 0 to infinity, which is the same as the domain of this function, which means my range of the overall function, because my domain here and my range from here are exactly the same, is just going to be whatever the original, what the range of this function is, which is f of g of x is an element of 1 to infinity, because that's the range of this function. My domain here, that remains the same because my range of the inner function is, so the range of this function is negative infinity to negative 3. That's my domain. My range is from 0 to infinity. So because that and that are the same, then my range of the final function, the outer function, is going to be the same as the range of the inner function. Okay, state the range of f of h of x. F of h of x. Okay, so I'm just going to write domain range. F was 0 to infinity. My range was 1 to infinity. Here, my domain is all reals. My range is 3 to infinity. So if I sub this into this, the only values that are going to be used are 3 to infinity. So we need to work out, for this function, if we use 3 to infinity, so if I said f of 3, that's root 3 plus 1, which is 2. So that's my lowest value, I think. Try a bigger value. What's something that's nice? 8. F of 8. If I put 8 into it, I get root 8 plus 1, which is 9. Square root of 9 is 3. So my range for f of h of x, that is, I said 2 to infinity, because it's just going to get bigger. Because we use values from 3 to infinity, and if I put 3 into this function, I get 3 plus 1, which is 4, square root, I get 2. So it goes from 2 to infinity. Okay, for events A and B, a sample space, probability of A given B is that, probability of B given A is that, probability of A intersects B is P. Find A in terms of P. Okay, so we need this one. The probability of B given A is equal to the probability of B intersects A, or A intersects B, they're the same thing, over the probability of A. So we know the probability of A is the probability that B intersects A, which is P, over the probability of B given A, which is a quarter. Therefore, that is 4P. So we know that the probability of A is 4P. What's the probability of B going to be? So that's the same sort of thing. The probability of B is going to be P over this, because it's the probability of A intersects B over the probability of A given B. So I'm going to get P over 1/5, which is 5P. Okay, if we want the probability of A naught intersects B naught in terms of P, we know A intersects B is P. We know the probability of A is 4P, so that's got to be 3P. The probability of B is 5P, so that's got to be 4P. So the probability that A intersects A naught intersects B naught is everything out here. So it's going to be 1 minus everything in here. So 3p, 4p, 8p. So that's the probability of A naught intersects B naught, 1 minus 8p. Given that the probability of A or B is less than or equal to 1/5, state the possible value interval for P. So it's not just a single value. Okay, A or B, well, that's everything in here. So it's 8p is less than or equal to 1/5. So P is less than or equal to 1/40. That is an interval. But can P be negative? No, it can't, because we'd have negative probabilities. So that's our answer. Because P has to be greater than 0, because the probability of A given B is greater than 0, so therefore P has to be greater than 0. So it's between 0 and 1/40. And that's what it means by interval. I think a lot of people would have left the greater than or equal to 0 out of that. They would have stuffed that up. It can be 1/40 though. Okay, this is the nasty question, because first let's have a look. I've got root x, 1 minus x, between 0 and 1. Calculate the area between the graph of f and the x-axis. So we want 0 to 1. I'm going to rewrite that to be x to the half minus x to the 3/2, because that's x to the half, and then that's x to the half times x to the 1, which is x to the 3/2. So I get x to the half minus x to the 3/2 dx, which is, if I add 1 to that power, I get 3/2, and when I divide by 3/2, I get 2/3, x to the 3/2, minus, if I add 1 to that power, I get 5/2, so it's going to be 2/5, x to the 5/2. They've given us nice numbers to work with here. If I put 1 in, I get 2/3 times 1, and 1 to the power of anything is 1, minus 2/3 minus, put 1 into there, I get 2/5, and then subtract 0, because when I put 0 into both of them, it's 0. Which is, if I put that on 15, I get 10/15, minus, if I put that on 15, I get 6/15, which is 4/15. So that's that area, 4/15. Okay, for the interval from 0 to 1, show that the gradient of the tangent is given by that. Okay, so I've got to derive it. We could use product rule, or we could just use that rule. So f of x, f dash of x, is 1/2 x to the negative 1/2 minus 3/2 x to the half. Okay, so I get 1/2 root x minus 3 root x on 2, which means I've got to multiply that by root x on root x, which is 1 minus 3x on 2 root x, which is what they wanted us to show. So all I did was differentiate them individually and then get them over a common factor of 2 root x. Okay, the edges of a right angled triangle ABC are in line segments AC and then CB. Okay, and the line segment, which are tangents to the graph of F. So that's a tangent, and then that's a tangent. Line segment AB, which is part of the horizontal axis, shown. Let theta be the angle AC makes. So there's theta, with a positive direction x-axis where it's between 45 and 90. So it could only get bigger. Like if you move it in, that's going to get bigger. Find the equation of the line through B and C in the form y equals mx plus c for theta equals 45. So I want to find the equation of this line. We know this angle is 45. So tan of 45 is equal to 1. So the gradient of that line is 1. So the gradient of that line, so m equals 1, m perpendicular, that's got to be -1, the gradient of that line. What else do we know? Okay, when does that gradient equal negative 1? 1 minus 3x on 2 root x is equal to negative 1. 1 minus 3x is equal to negative 2 root x. Bring your 3x to the other side. 3x minus 2 root x minus 1 equals 0. Okay, we've got a square root, so it's hard to factorize. So I'd let a equal root x. So a squared is equal to x, and then sub that in. So I get 3a squared minus 2a minus 1 equals 0. 3a, a, 1, 1, negative, and positive, because I want 3a squared minus 3a plus 1a. So a equals negative 1/3, or a. So root x equals negative 1/3. Root x equals 1. This one's not feasible. Therefore, x equals 1. Now that was a problem because this says it's defined for 0 to 1. So the derivative wouldn't be defined on the endpoint, but we have to assume that it's okay. And it is if the function's continuous, but bad question. Anyway, if x equals 1, y is equal to, if I put it into here, 1 times 1 minus 1, 1 times, so I get 0. And we know that m is negative 1 from up here. So y minus 0 is equal to m x minus 1. Therefore, y, I'm going to say CB is equal to negative x plus 1. So that's the equation of that line. Find the coordinates of C when x equals 45. Okay, I'm just trying to think, is there any way I can do this without... We know that the gradient here has to equal 1, so we've got to find the equation of this line, and then find where the two lines intersect. So the gradient's 1. What's the gradient? 1 minus 3x on 2 root x equals 1. Bring your 2 root x to the other side, so 1 minus 3x is equal to 2 root x. 3x, bring that over, plus 2 root x minus 1 equals 0. This time let b equal root x. B squared is equal to x. So I get 3b squared plus 2b minus 1 is 0. 3b, oops, b. I've got to have a 1 and a 1, and I want to end up with a plus 2b. So I get b equals 1/3, or b equals negative 1. b, so x, root x equals 1/3, and then root x equals negative 1. Here we're going to get x equals 1/9. Here, x, no solution. So x equals 1/9 is when the gradient is equal to 1. Sorry, I've got a throat. Okay, if x equals 1/9, y equals the square root of 1/9, 1 minus 1/9, which is 1 on 3 times 8 on 9, which is 8 on 27. So we've got x, we've got y, and we know that m is equal to 1. So y minus 8 on 27 is equal to m, x minus 1 on 9. Y is equal to x minus 1 on 9 plus 8 on 27. 7 on 27. 1/3. Is that right? 1 minus 1 on 9, which is 8 on 9. 1/3 times I'll stuff something up here, I think. So x equals 1 on 9. If I put 1 on 9 into that formula, I get 1/3 times 1 minus 1 on 9, which is 8 on 9, which is 8 on 27. I know that x is 1/9. Here I've got to put that on 27. So y equals x. Actually, if I put it on 27, I get minus 3 on 27 plus 8 on 27, which is plus 5 on 27. So that is y of AC. So if we want to see when they're equal, we say y of AC equals y of AB, and then we get x plus 5 on 27 equals negative x plus 1. 2x equals 1 minus 5 on 27, which is 22 on 27. So x equals 11 on 27. And we know that y is x plus 5 on 27. So the intersection is 11 on 27, and then 11 on 27 plus 5 on 27, which is 16 on 27, which I guess could be right, 11 on 27. So that was 45, 11 on 27. We don't really know what that is. Doesn't really matter. Let's assume we're right. That's it. Okay, hopefully I got through that in the time. I have no idea how long that took. So 11 on 27, 16 on 27. Answered that with the equation of the line. Show the gradient, that one's easy. Calculate the area, we've calculated the area. State the largest possible interval, yep. A naught intersects B naught, which is everything out here. So it's 1 minus what's inside, that's right. That's right, we didn't need to find that, but we did just to create that Venn diagram. That all looks right, we went through that slowly. All possible solutions, 0 on pi. So tan's positive in the first, and in the second, first again, when it's equal to root 3. But we could also have it equal to negative root 3, so that'll be in the second, which is 2 pi on 3. State all possible values of tan theta, so you just leave it tan theta equals. And we did that twice, so it's got to be right. That will be right. That's right, because you get 3 of the same in the row. That's right. Smallest integer value for n, which is 1875. That graph looks right. Like I said, probably the main thing is that this looks like it's stationary here, like it's becoming 0. I think if you had have just done that and not shown that that's a stationary point, you would have lost a mark. That's easy because it's just show that. That's in that form. So log E12. We'd think that you want to get something very similar, and we did. G dash of 1. Of course here, I'll just quickly show you, you could have used the chain rule as well. Just for anyone who doesn't know how to do it the quick way. Okay, so let u equal 2 minus x cubed. Therefore, g equals u cubed. U dash, when I derive that, I get negative 3x squared. G dash, when I derive that, I get 3u squared. G dash of x is these two things multiplied together. So negative 9, that's that and that. X squared times u squared, which is 2 minus x cubed squared, because we know that u is that. And then g dash of 1, negative 9 times 1, 2 minus 1 squared, it's just going to be negative 9. This one here, u, v, u dash, v dash. The rule, remember, it's got to be v, f dash of u on v. It's v u dash minus u v dash on v squared. So v has to come first, so just make sure you do that. We did that when I subtract, yep. Okay, I think we've got 100%. Good luck with this year's one. Hopefully it's better. Bye.